Hello, everybody. Thanks so much for the opportunity. Today, we have a really exciting panel. My name is Dennis Wall, and I'll be moderating. The panel is on AI in pediatrics and opportunities and barriers. And the panelists today represent a perfect mix of individuals who've been working at the frontiers of artificial intelligence and trying to bring them to practice in different ways. That includes work that I have done, which I'll get into, and hopefully some of the panelists will ask me about, but work that Dr. Washington has done, that Lauren has done, and that Catalin have done and are doing right now to try to penetrate the market, so to speak, of pediatrics, really to bridge the gap between invention, innovation, and actual practical impact. And finding ways to do that like cross the thinking of what is medical and what is a medical device, and where does that bleed into education and early learning, and where are the barriers, if any, between pediatric healthcare and early learning and development in children. The majority of kids, thankfully, are not in the hospital, are not receiving hospital-based care, and they're out somewhere else. And that's where that outpatient thinking comes into play, and that's where a lot of the opportunities for artificial intelligence can take hold, whether they become solutions that are covered by medical insurance under certain policies as medical benefits, or they're direct-to-consumer solutions that increase the reach and enable a rapid reach to the greater population in need. And so I thought we'd begin with each one of the panelists just giving their introduction, starting with Lauren, and then going to Peter, and then going to Catalin, and then we'll take it from there.
Awesome. Well, good morning, everyone. Nice to see you. I work at the Stanford Center on Early Childhood, directed by Phil Fisher as their senior machine learning engineer. At the center, we use AI, and are we just doing short introductions or also saying what we work on?
Say.
Great.
That's the introduction. You must say what you're working on.
Awesome. So we use AI in two different projects at the center. One is focused on understanding and identifying certain types of interactions between young children and the caregivers in their lives. We've had a program ongoing for about 10 years called FIND, Filming Interactions to Nurture Development, where similarly to if you're a new teacher in a classroom and someone might come observe you, we take observational videos of educators, parents, really anyone important in the life of a young child, and then we show video examples to those adults. Here's a time where you named what your child was doing or supported and encouraged what your child is doing. Here's why that's so important to their brain development. And we've been using AI to expedite the video analysis piece of that. The second project that we work on, which I'm not directly involved in, is our nationwide rapid survey, which started amidst the pandemic, where we survey young families or caregivers of young children about the wellness of those children and challenges experienced by those families, and then use AI to expand the type of data and the type of responses that we can analyze in order to inform policy.
Peter.
All right. Hello, everyone. I'm Peter. I am a new assistant professor at UCSF in the new division of clinical informatics and digital transformation, which I believe our keynote speaker yesterday is our division chief for, so very lucky to be in that division. And I run a research lab in consumer digital health informatics. So what that means is building digital diagnostics, therapies, and interventions using data coming from smartphones, wearables, and other consumer apps that we build ourselves, and for a variety of conditions that we're passionate about, including in developmental pediatrics. So I actually started in the Wall Lab, in Dennis's lab, working on a project that Catalin led. So I'm very excited to be on this panel. And my PhD was on digital diagnostics for autism using smartphones and methods to make that happen. Now I'm running a project that's building upon that work called Social Play, where we're trying to tackle a few key problems in AI for pediatrics. And so I'm sure we'll talk more about those in the panel, but just very briefly. The first being that it can be very difficult to have AI models achieve specificity when distinguishing between highly overlapping but distinct conditions. In our case, autism and ADHD, where you can have, for example, a child with just a diagnosis of autism or just ADHD, or both, or none. And the way that AI models are set up today aren't really able to handle that. So we're trying to recruit a cohort that spans those 4 different scenarios, which is in itself quite challenging, and then trying to make computational methods work for that. The second challenge that we're addressing here is we're targeting a slightly older population, so adolescents. And so for pediatric developmental delays, early diagnosis is the best, but the reality of the situation that we're in is that a lot of kids get missed. And so there are still many benefits of diagnosing later in life. And so to do that, we're building fun 2-player games, something that teenagers will do anyways. So recreating that, but trying to make the games collect useful diagnostic information for autism versus ADHD versus both versus none, and tackling engagement and retention, which for consumer devices is a major challenge, and especially for pediatrics is an especially major challenge, and especially with a ADHD population, there's a third layer to that. So happy to talk more about that. And I think that leads nicely into Catalin's work.
Yeah, absolutely. Okay, cool. Well, thanks so much for having us. It's a real special treat to do this. It's kind of a reunion for at least the 3 of us. Yeah. So I have been working on applied AI at Stanford with Dennis. I guess if we're calling each other other doctors, Dr. Wall. I'm the only non-doctor on this panel, I think, because I dropped out of my PhD twice. Yeah, exactly. Well, yeah, maybe if things either go very well or very poorly, I'll return. I have been trying to harness the, prolific tools that we've been seeing to mature around us to, I guess, maximize the potential of all kids. That included, my cousin who grew up with autism. And motivated us to build a learning aid for autistic kids in the form of pair smart glasses when Google Glass first came out. As you put them on and they use facial expression recognition to tell you how people around you seem to feel. We built that up, ran clinical trials out of Dennis's lab, eventually got an FDA breakthrough designation, and then licensed it out to one of Dennis's company where, Dennis told me I can say this, where it went to die, basically. And so in some ways, that's a little bit of a cautionary tale of the maybe regulatory hurdles that, honestly also consumer hurdles, but definitely also regulatory hurdles that we face trying to, realize impact here in the form of a Class 2 medical device. I got a little bit disillusioned with that version of the world and ended up going down the consumer route, hence the sort of 2 dropouts, and ended up starting a company with 2 co-founders, a clinical child psychologist and an edtech entrepreneur and former teacher, building, I guess you could say, an AI tutor. And so that's what Ello is. We're building an AI tutor, starting with reading, the foundation of all other learning. You learn to read, and then you read to learn. And so we have this currently elephant named Ello, who sits like on your tablet and or phone or whatever, and listens to you read out loud, helps you when you get stuck, motivates you to keep going, and then inspires a love for reading. Let's see. My wife's a pediatrician. I've spent a bit of time in that sort of sphere, and obviously, I believe we have an opportunity to make a tremendous impact at scale here, right? We are listening to kids interact with AI now on like a daily basis and at a sort of massive scale. I think we have to face the reality that our kids are gonna grow up talking to computers, and that's just gonna be like a normal thing. And those computers are gonna like get to know them better than their pediatricians or their parents or in some instances, like a lot of other people. And so we believe that there's an amazing amount of good to be unlocked in that version of the world. We believe that making sure that that's a good thing is a global challenge. I just spent a month with our team in Kenya doing a bunch of on-the-ground testing, play testing there of a new application where basically the entire interaction is becoming agent-driven. So you sort of have the AI controlling the UX and everything else. And it's essentially a continuous free-form conversation with the child embarking on their own curiosity-led learning path. So, you know, in summary, I think that challenge, figuring out how to scale one-on-one, instruction in the first instance, but then everything else that comes with it, I think has the power to become sort of one of the most impactful global applications of AI.
Thank you. So I'll start with just a couple things. I'm sort of unpacking some of these comments that our great speakers just gave. This notion of computers getting to know your children better maybe than some of the primary caregivers that the child's interacting with is maybe a scary notion. And one of the things that we probably want to think about is control, like control of quality, artificial intelligence, agencies, drift, and things of that nature. And so I think maybe in that case, some of the work, Lauren, that you're doing might actually come into play, where you're recording the interactions of a dyad, dyad here being a parent probably, or a primary caregiver of one kind, and the child. Is that an opportunity for us to infuse some control over the agency as the child begins to spend more time with the computer?
It's an interesting question. None of the AI applications that we develop are actually child-facing. So in terms of kind of the safety and the agency of the family, I think the way that we integrate AI is unique on this panel because the application for the FIND program, where we video adults and children, has actually been ongoing for about 10 years. So we started implementing this program 10 years ago, evaluated the impact, saw some really exciting impact on child language development and behavioral challenges. And the AI kind of comes into play in order to expedite the creation of that feedback. So there's actually, once you take a video of the adult and child, that person is usually a coach employed maybe by the state or by Stanford. It takes that practitioner a really long time to create video feedback for that parent. Imagine bringing it into iMovie and then looking for all the interactions that you're trying to find and then formatting that the right way. So that's where the AI piece comes into play, is allowing the practitioner to do that process more quickly. I think that there's a lot of opportunity to study a lot of different social phenomena from these types of videos. But I wouldn't say necessarily that the child's agency in interacting with AI is really being impacted here, because they're not, I would say, compared to with Ello, and I'd be curious your thoughts on this, they're not directly interacting with the AI themselves.
Understood. But Peter, you're building games to engage individuals who have late diagnoses, maybe, with other individuals who can support them. Do you want to speak a little bit about that and the way that AI plays a role?
Yeah, happy to. And building off of this idea of trust with the AI, it's interesting because with traditional non-generative AI, like classification models, we have evaluation metrics, accuracy, sensitivity, specificity, or fairness metrics, right? Like demographic parity, equalized odds. We don't necessarily have equivalent metrics for generative AI. How do you evaluate generative AI as an open-ended question? And so that's something that just to that point. But for what we're building on our diagnostic AI, which is perhaps more of the traditional predictive AI, for social play, we try to align all of our models with sort of the 4 pillars of human-centered AI. I know there's a HAI Center here. And actually, I don't know if they say these are the 4 pillars, but my interpretation of the 4 pillars that I say in my class are explainability, privacy, fairness, and usability. And so we want to make sure that we evaluate all the models across all of those. And in pediatric populations, it gets interesting. And it's not like the default ways for evaluating all 4 of those in general do not necessarily apply in pediatrics. So just a quick example, in private, for privacy, there's there's consent and assent, but we're typically working with triads in all of these situations. So in clinical situations, there's the parent, there's the child, and there's a clinician or educator. And so that's at least 3. And once you get into human in the loop AI, which we're also doing, there's perhaps a 4th stakeholder. So this gets really complicated, and it requires human-computer interaction innovations that I have not seen. I haven't seen any papers on this, but I think if anyone's interested in collaborating on this type of thing, let me know.
Yeah, I appreciate Peter's thoughts on human in the loop AI. And the interaction between that and trying to evaluate large language models and generated output. We also rely on kind of human in the loop to once output is generated, kind of correct that and make sure it's appropriate before providing it back to the parents and children.
Great. I'm going to shift gears a little bit to reflect the fact that we're in a hospital, or at least on a roof of the hospital. And maybe many of the audience members are working in the hospital or are practicing doctors of one kind or another, and what the world of invention and artificial intelligence means to you relative to perhaps what it might mean to some of us. I could say that I've taken an AI-enabled device through the FDA as a diagnostic solution for autism. It was the first ever autism diagnostic approved by the FDA of any kind. But one of the very few at that time that had been approved for artificial intelligence as a software, as a medical device, also approved with what's referred to as a predetermined change control plan, which is an FDA guideline set of procedures that enables you to adapt the AI without having to submit regulatory documentation like a 510K. So a powerful moment in history, I think, and I say history because it is now becoming like ancient history. It was June 2nd. It was like the 4-year anniversary was a couple days ago, June 2nd, 2021. And it has systematically struggled to come to market. It was meant to be a medical benefit and therefore meant to be adopted by insurance, meant to be covered by Medicaid, meant to be covered by commercial insurances as a medical benefit. But upon reflection, you go back and look at the FDA and you can see what are they evaluating among the 4 pillars of artificial intelligence, for example. And really, they're only looking at maybe the first 2, explainability